Number 5, we're given the integral of cosine squared 3x times sine 3x dx. So we will check if we can use the formula integral of u to the n du equal to u to the n plus 1 over or divided by n plus 1 plus c. So let us find out from this given what is u. So we consider this u cosine 3x. If we consider this as our u, where our n is equal to 2, then our du is equal to the derivative of cosine, that is minus sine u, which is 3x, times 3 dx. Okay, so we can then rewrite this integral of cosine 3x. So we can rewrite this part here as cosine 3x raised to power 2 times sine 3x dx. So remember that we can apply this formula only if we have a perfect du. Now if you look at the given and compare this, if you can consider this as our u to the n, so this must be our du. But when you do this substitution, u equal to cosine 3x, our du is minus 3 sine 3 dx, or we can rewrite this as minus 3 sine 3x dx. If we compare this du to the given du, so our given du is not perfect du. There's a missing here, or lacking of minus 3. So in order for us to apply this formula, so we need a perfect du. So to do that, we have to balance. We have to supply what is lacking in this du here, and then balance it to so one way to do it, by the way, I will continue it here. Okay, first we need to rewrite this part here, integral of cosine 3x squared sine 3x dx. Then we will write the missing part, which is minus 3. So we don't have the minus 3 here, so we have to supply it here to make it a perfect du. So we have now a complete or perfect du, similar to our du here after the substitution, and we have to balance it. We have to multiply this with negative 1/3. So we're not changing actually. So when we put this minus 3 here, so we are now changing the integrand. So now we are violating the rule here. So to make it neutral or nothing happens, actually, is to balance it. It means that what you have added, it should be subtracted. So it's just like doing something to neutralize. So when you multiply this by negative 3, our purpose is to complete our du here. But now the result is we're changing, the integrand. So to balance it, we multiply it by minus 1/3. So it is as if that we're not doing anything here, because minus 1/3 multiplied by minus 3, so that is just equal to 1. So 1 multiplied by the original integrand, so it will come back to the original integral. Okay, so now applying the formula, because we can now use this formula, the power formula, when we have already a perfect du. So this will be minus 1/3. Okay, applying this formula, we have u to the n plus 1. Our u is cosine 3x raised to power n plus 1. Now n plus 1, so 2 plus 1, which is equal to 3. Then divide this by n plus 1, so n plus 1, which is equivalent to 3. Then plus our constant of integration. So we have 1/3. This one is a denominator. This is a denominator, so you just multiply both denominators. So we have minus 1/9. Then cosine 3x raised to power 3 plus c, or this is negative 1/9 cosine 3x. So we follow the original position of the 3 here in our given. Okay, then plus c. So this is our final answer. Another way of doing it is something like this. From our given, another solution. If you find it confusing why we are doing it, adding minus 3 here, and then also putting minus 1/3 here to balance. So if you're not convinced on that, or if you are confused with that method, then here's the other solution. So using the full substitution method. So integral of cosine squared 3x sine 3x dx, and we will let our u here be cosine 3x, our n is equal to 2, then our du is equal to minus sine 3x 3 dx, or du is equal to minus 3. So you write the constant in front of the trigonometric function sine. So sine 3x dx. So avoid multiplying 3 and 3x. So that should not be the way to do it. And then we have u equal to cosine 3x. So we let this part here as our u. So we have now integral of u to the n, supposedly du, so that we can follow this formula. Okay, so now we have to express our du in terms of dx, but we need to express our dx here in terms of our du, which is minus 3. What I mean is we need to express this one, the original part of the integral, in terms of our du. So we have to divide both sides by 3, from this equation. So du divided by 3 equal to minus 3 sine 3x dx, divide this by 3 also. Okay, so or divide it by minus 3. Alright, so we will get the original sine 3x dx. So this becomes minus 3 divided by minus 3 is 1. So here we have du over minus 3 equal to sine 3x dx. So using the substitution method, so integral of, we have, instead of writing cosine 3x sine 3x dx, so we can rewrite u, integral of u to the n. Our n is 2, then our du, which is equivalent to this one. So our sine 3x dx, which is this one, is equivalent to du over minus 3. So we have to multiply this by du divided by minus 3, and we can rewrite this as, this is a denominator, negative, so we can rewrite this is, and this is constant, so we can write this as minus 1/3 integral of u to the n du. So minus 1/3 integral of u to the n, our n is equal to 2, then du. So this is now a perfect du, so we can apply the formula. We have minus 1/3 integral of u to the n du is equal to u to the n plus 1, where our n is 2, so 2 plus 1 is equal to 3, divided by n plus 1, or 3, then plus c. So minus 1/3 times, so we can rewrite this as minus 1/3 times, you can write u cube here, and then we have 1/3. Okay, so 1/3 times u cube, so that is the same as u cube divided by 3, then plus c, or equal to 1/3 times 1/3 is negative, so this is minus 1/9 times u cube plus c. Then substitute back the value. So substitute back u, which is equivalent to cosine 3x. So therefore we have minus 1/9 u, which is cosine 3x, then plus c, or equal to minus 1/9 cosine cube 3x and plus the constant of integration c. So this is our final answer. So if you look at this, they are just the same as the above solution or result. Okay, so I hope you understand this process, and good luck to your coming final examinations. Thank you.